So good evening to all of you. My name is Mr. Teow. I will call me Mr. Teow. Today I will be teaching you the additional mathematics for Form 5. Okay, so this is Form 5 additional mathematics. And your Form 5 additional mathematics, you are going to have 8 chapters. And today we are going to enter the very first chapter, which is about circular measure. So my name is Mr. Teow. You can see here. So circular measure, you can see is related to circle, is measurement related to circle. So we are going to look into what circular measure is. Before we enter this chapter, we are going to recall on what is our circular measure and what are measurement related to circle. So before this, you are actually touched this chapter in which you have learned the word degree before in your form 1 until form 4. So as you still remember, the word degree here you did not with the symbol this symbol. This is the degree symbol. It is actually the angle value between the two lines. This is the line 1 and you have line 2. So this is your center and you're actually having an angle here. This is the angle between two lines, which before this you did not as the degree or you have denoted with this symbol. That you still remember your example 36 degree, you have 39 degree and so far so on. So if you still remember, you have actually two formula that you have learned. Which the first formula is for circumference or we call length. So here you actually have a theta degree over 360 times 2 pi r. And you actually have another which is this area formula. You have theta degree over 360 times pi r square. And you still remember if you're having circle, you actually takes the whole degree, which your theta degree is 360. So that's why you have 360 pi over 360 times 2 pi r, and you have cancelled both of these and you're only left with 2 pi r. This is what formula you have learned before. But for your better remembering, you will still remember these two formulas. Okay. So in this chapter, we are going to learn a new value which is called radian or rad. So starting from today, which is after you have entered this chapter 1, additional mathematics 5, you should remember that angle value or angle value, you have three types of angle value, which the first type is your degree, second type is radian, and the third type is gradient. You will not learn additional mathematics. You will only learn these two, which is the degree and radian, which will be the focus of this chapter. So you should remember that all the three values, when you apply to the formula, you should bring you the same answer. So there's no difference in terms of answer. Okay. So let us enter into the calculator teaching. So your calculator, this is your calculator. And when you enter this calculator, the initial display, your calculator will display degree mode, which you have the D here. This is what you can see in top of the calculator. And when you want to change the value to radian, okay, you can actually change the mode to radian by press the mode 4 times and you choose number 2. You will get this R in the top of the calculator. So by using this every time when you click the slide 2, the first mode here, this is the first mode. Calculator will read you as sine 2 theta, sorry 2 degree, while the radian mode, which is this second mode, you will actually get sine 2 radian. So clear, you can remember this one. You should always clear the mode by press Shift plus mod to clear all after use. When we end all the fraction, when you type into this calculator, you should come with a bracket. For example, when you find 4 over 5 radian, when you enter this second mode, you should always remember sine bracket 4 over 5 when you're using the radian mode. And you need to remember to clear the mode after you use the calculator. Okay, so now let us look into the next chapter, which is how you convert the radian to degree and vice versa. So as what you can see, theta, you have theta degree and you have theta radian. So when you want to convert theta degree to theta radian, you need to multiply 2 pi over 360 and vice versa, divide by 2 pi over 360. Okay, so if you forgot in this exam, then how we are going to look into the way to get it back. Okay, so let us look into this, how to calculate the arc length using Radian. So the first one, you have this formula, which is S equal to R theta. This S refer to arc length, your R refer to radius, and this theta refer to theta radian. Okay, this is the easy way for you to remember. This is the formula is given in your exam. So by compare these two formula, you should get your slide 5 formula. First of all, you take this S equal to theta degree over 360 times 2 pi r. You learn this one in your slide 2 and you learn it from form 1 to form 4. And another one, this formula is the new formula that you learn this chapter. This is S equal to R theta radian. So when you compare these two formulas, you have this and you finally get this formula in which theta degree times 2 pi over 360 you get theta radian. So your theta radian equal to theta degree times 2 pi over 360 and vice versa your theta degree equal to theta radian divided by 2 pi over 360. So remember the place in calculator, these two you should put a bracket. Okay, so you remember one thing. This is the thing that you must always remember. 2 pi equals 360. Remember this until trigonometry later. You have one chapter trigo, which you will put this 2 pi into your trigonometry. Okay, now let us look into the first example. So the first example, the questions actually ask you to convert a 45 degree into radian. Okay, so when you convert the 45 degree into radian, so you remember the formula 2 pi equal to 360. So when you have 2 pi equal to 360 degree, this is 2 pi, you have 360 degree. So what you're going to do when you want to convert from 45 degree, you should multiply with 2 pi over 360. So the answer you get is 0.7854 radian. Remember this one. Okay, so the next one you are going to see how to convert 1.5 radian into degree back. So 1.5 radian you want to convert into degree. So the first step you have to do is for 1.5 radian you need to divide by 2 pi over 360 and you will get back 35.94 degree based on this formula. 2 pi equal to 360. Remember. So you can see this. Okay, let us see how we link 2 pi equal to 360 to our formula. 2 pi refer to radian, 360 refer to degree. Okay, so when you want to get your degree, what you do? So you will, okay, so what you do? Okay, you bring this one into here. So you will get 2 pi over 360 times. Okay, so you will get what you get. You will get 2 pi over 360. When 2 pi over 360, you move this one here, you get 1. Okay, so this one you will refer to 2 pi over 2 pi multiplied with degree. So you will get your radian. Okay, and vice versa, what you will get, you will just bring this one here, you divide, and you will get back into your degree. Okay, so you will remember, always remember, when you put radian, always smaller than your degree. So you remember, okay, I put a black color here. Okay, radian always smaller than degree. So when you get your radian bigger than degree, you know answer is okay. So let us look into another questions. So this question you should answer by yourself. So first question, you need to convert 230 degree into radian. Second, you need to convert 1.5 radian into degree. So I put this question, and the third question is this question. So I will put these questions for you to do, and we will discuss this one in the next video. Okay, remember sometimes you will need to draw the shape the illustration and learn to highlight your important points. Okay, for example, this one your important point, and this one important point is this. Okay, so next, let us look into example 2. So example 2 related to this formula S equal to R theta radian. So you must first find the arc length of the sector with radius 3 and center O in 2 radian. Okay, so if you don't see any picture from here, you need to draw this. So the first one you need a sector, so you draw a sector. So after you draw a sector, you see it's the arc length. So this is the arc length. Okay, so this is actually the length that you want to see. This arc length. Okay, so from this arc length, what you are going to do, you have radius 3 centimeter, and you actually have center O here, and you have 2 radian, this one. So you saw this picture. So when you apply this formula, you will get 6 centimeter. You can see here, actually you have S equal to 3 centimeter, and you multiply with 2 radian. So you get 6 centimeter. Okay, so the second question is a group of 4 identical pendulum box. So this is the pendulum box 1, pendulum box 2, pendulum box 3, and we have 4 pendulum box. As you can see in this picture, AB is actually length 23. So you have AB length 23. Each pendulum has a diameter of 1 centimeter, and each string has a length of 5 centimeter. So you need to find the angle of oscillation of the pendulum in radian and the length of each oscillation in centimeter. So we will first of all, at the step 1, we will need to label this. So how to label this one? Okay, we are going to see AB is 23. So from this figure, 23 start from here to here. So have 23 centimeter in this place. So from here, 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 we have 23 centimeter. And then each pendulum ball have diameter 1 centimeter. So you get to see 1 centimeter is equal to this is a center. So the 1 centimeter should come here to here. Okay, however, you should know radius. So I made this pendulum bigger. This is a pendulum ball. Okay, you should see this is a radius. So when you say, okay, your center is here, when you say diameter 1 centimeter, it means the radius is 0.5 centimeter. And you should know this is a 4 identical pendulum box, in which each box have the same radius. So this refers to 1 centimeter, have 1 centimeter and 1 centimeter in each of here, from this center to this center. Okay, and then each string you have 5 centimeter, so this is your string 5 centimeter. And then you need to find the angle of oscillation. So this is your angle of oscillation. Okay, I draw here angle of oscillation. So I put in that color. So you can see this angle of oscillation. And you have another one is actually the length of oscillation. So this is the length of each oscillation. Okay. So we are going to see how to answer this. Okay, so in the first questions, okay, you see the diameter is 1 centimeter. So you can see this is what I mean by 1 centimeter. So we get to know that the length between the point of the string joint and the leftist of the point and the rightest of the position is 5 centimeter. So you have one box here. This is point starting, and you have actually the dotted line here. This is your ending. You have dotted line 2 ending, dotted line 3 ending, dotted line 4 ending, and so far so on. So from here, actually each of these go to 1 centimeter. So you have 5 centimeter in this place. Okay, why? Because you have, okay, as you have 1 centimeter. So you need to take 23 centimeter minus with 3 times 1 centimeter divide by, you have 4 pendulums, so divide by 4. So what you can get, you will get 5 centimeter, as you can see here. So by using trigonometry theory, so you get the trigonometry theory, the angle oscillation should be 2 tangent of this 5 over 2 over 5 equal to 2 times 30 degree. So where you get this tangent 5 over 2 over 5, actually you will take it from here. Because this is 5, okay, you can see this is 5. And then what you have here, you have half half. So this one equal to this one. So you take this one equal to this one, this one, this one, and this one, this one here. Okay, so that's why you take this. You can make this triangle because you have 5 centimeter over 2 here and 5 centimeter. So you form a trigonometry. Okay, so from here you get 60 degree. So it's 2 times 30, you get 60 degree. Remember, when for a calculator, you must have a bracket. So you take 60 degree and you want to convert back into radian. So that's why you can see, you still remember, degree must be bigger than radian. So radian must smaller than degree. So what you do, you have 2 pi equal to 360. So you convert it to this one. So when 2 pi equal to 360, so how to make it smaller? You must multiply with 2 pi over 360. So the answer will be smaller. So the pi over 3 radian, this is your answer. And what is angle of oscillation? So this is the angle of oscillation. So you take out this sector, you draw this sector. Okay, so when you draw this sector, you take 5 centimeter, you have pi over 3 radian. So they multiply, automatically you will get S equal to 5 pi over 3 centimeter. Okay, so this is a question you should try by yourself on these questions. The first question, you should find the radius when a sector BOC. So you need to draw the sector BOC with a center O have a length of 10 centimeter and the pi BOC of 2.5, 2.7 radians. Second one, you to find total of two identical sectors, center O, radius 2 centimeter, and the angle at O is 2 radians. Third one, this is the plan of the circular stadium. See this stadium. So the owner would like to fence the whole compound. Distance from O to A is 5 meters. If angle AOB is 0.7 radians, you should find the length of fence needed for this compound in meter. Okay, so you have to find it in meter. So you can try these questions. We will still discuss in the next video. So we are going to look into these exam focus questions, which is on the Johor questions. This is the Johor questions 2021. So we are going to look into these exam focus questions. So we're going to look into this diagram 5. Okay, so diagram 5 actually shows a semicircle or ABCD with center O and a right angle triangle ADE. So we will see what is center O and right angle triangle ADE. Okay, so you can see this is the sector with center O, ABCD, and this is your right angle triangle ADE. Okay, so we'll go into this question. Okay, it's given that the length of ED is 10 centimeter. So ED is 10 centimeter. This is the ED. Okay, and the radius of a semicircle OABCD is actually 6 centimeter. So you will see OABCD radius is 6 centimeter. So find your first question is you need to find the degree of EAD in radian. So when you see these questions, you must mark into the diagram in which you can see degree EAD. This is the E, this is the point A, this is the point D. So degree EAD refer to this angle. So we are going to look into this angle, how to calculate this angle in your radian. Okay, so the first step. Okay, when the first step, you must see this triangle. If you cannot see this triangle, make it bigger. Okay, so you have 10 centimeter and you have this one. How much is it? Okay, so first step, you need to find AD. How to find AD? AD equal to 6 centimeter times 2 equal to 12 centimeter. So this is also same as their diameter. So from here you can see this is a triangle. So the second step we need to use the tangent. then sec cos, which is the tangent. So how to get tangent? Tangent theta equal to tan over 12. So you need to find your theta. Okay, so to get this theta, you have actually two ways to get it. So the first way is by using calculator. So when you calculate it, you remember the mod 4 times and then for the 2, you get into radian. So by this, you can directly get the answer 0.6947 radian. Okay, second way, you can use the degree method, which if you calculate using degree method, you need to convert back into radian after you've done it. So this is how you get for the question number A. So question number 2, you need to find the length in CD. So where's your CD? Your CD is here. Okay, this is your CD. Okay, so remember when you calculate this CD, you need to calculate this is center, degree to center. Okay, so you can see this is the center. So how you want to get this degree? Okay, so you still remember from here 2 pi equal to 360. Still remember this one. So what's your pi? Your pi is 180 degrees Celsius. So half circle equal to pi. So how we are going to get this value? We are going to use 2 times of this one. How you get these 2 times? Okay, let us do it in a simple way. You have 6 centimeter here and you have another 6 centimeter here. So this, when you bring out, this is actually an identical triangle. Okay, so you can see this is 6 centimeter, this is 6 centimeter. Okay, this is a triangle in which is the same, we call it as summer here. You have two 6 centimeter. So since you have found this one, which is the 0.69 radian 47, you have two place. So what you have actually you have. Okay, so what you get here, this is actually pi. Okay, pi minus 0.6947 times 2, because this is a triangle which is the same as the side. Okay, so here how you are going to calculate this? You are going to take pi minus 0.6947 times 2. Okay, so you will get this one. Okay, and then how you will get another pi and minus this answer, you get this answer. However, I'm not going to do this because you can see this is actually 2 times this one. So you can come into another, still remember, you have this one you learned before. When you learn this during, okay, you can see, okay, you learn this. Okay, when you learn this, you learn this when you have this x and this is 2x. So you still remember angle at center is 2 times as angle at the heart. Okay. So from here, we are going to get this length in centimeter. So you can get this one by taking 2 multiplied with the degree here. So actually your degree, or you say this is angle COD equal to 2 times 0.6947. Then you will get the answer. Okay. The answer is 1.38. Okay, 1.3895. Okay, so this is the answer for angle. However, you want to get CD. So CD is this one. You still remember you play this 6. So when you want to get this CD, you should take S equal to, still remember this S equal to R theta radian. So your theta radian, your R is equal to 6. Theta radian is 1.3895. So your answer will be 8.8. 3, 3, 6, 9 centimeters. Okay, and this area C we are still having learned, so we will not discuss in this video. We will discuss this one in the next video. Okay, so for this second questions, it comes from 2021 Johor paper 2. So we are going to look into this diagram 2. This is your homework. Okay, so your diagram 2 shows two similar wings of fan. So I will note different color for you. OPQ is this settle. You can see this OPQ. And then you have OTR, which is this OTR, small one. This is OTR. Then you have another one is QSR, which is this upper one. This is QSR. Okay, so these are the three semicircle with the diameter. So you need to find the perimeter. And no need to find this one. This one you will learn in this next video. So for this question, you're going to answer it, and we will discuss this in the next video. So that's all from this video. So thanks for watching, and help us to share to more of the friends so that they will learn more on mathematics. So we'll see this next week, and I'm Mr. Teow. Thank you.